Hello. Today we will continue in section 7.2, talking about inverse functions. In the last videos, we were talking about one-to-one functions and how those relate to inverse functions is going to be seen today. So if f of x is a one-to-one function, then f to the negative 1 power of x is the inverse of that function. Now, we read that f to the negative 1 power of x, not like that, but as the inverse of the function of f of x. So a function must be one-to-one in order to find the inverse function. If it's not one-to-one, we cannot find the inverse function. And to find the inverse function, we are going to be switching the x and y values of the given function. So let's take a look at problem 5. Brianna is driving to the store. Here is a table, f of x, her distance in miles, and x, her time in minutes. And first part, we want to fill in the table using this graph below. So we can see along the x-axis, we have minutes, and along the y-axis, we have miles. So let's go ahead and fill in this table. We can see at time 0, her distance is also 0. She hasn't left yet, so that's when she gets started. At 1 minute, we read the graph here, it looks like she's about 0.5 miles. At 2 minutes, it's like they're between 1 and 2, so let's call it 1.5 miles, approximately there. At 3 minutes, she will have driven 3 miles. At 4 minutes, she's going to be at 3.5 miles. And at 5 minutes, she will have gone 4 miles. Okay, so now that we have that filled in, let's go ahead and talk about what the domain of f is. So remember that the domain are our x values. Now, these are specific points that are on there, and we can see those points labeled. However, since we're dealing with time, it's this continuous kind of function that we have here. So our domain is going to be 0. So we're looking at it from left to right. Furthest to the right it goes is 5 minutes. So from 0 to 5 and including 0 and 5. So make sure those are in the square brackets. The range, we'll look at it from bottom to top because those are our y values. Again, it starts at 0. And this time, our highest value that it gets up to is 4. All right, so now it's asking us to fill in this table, and then we're going to graph it on the same grid over here. So it wants us now to find the values for our inverse function. So here's our function f of x. The inverse function means we need to switch those inputs and outputs. So when I do that, well, we'll still have 0, 0, but now my input will be 0.5 and my output will be 1. And we'll keep writing those down. So then I've got 1.5 and 2. Do you see how I'm just switching those x and y values? 3 and 3, 3.5, and then 4, and then 4 and 5. Okay, so now let's graph those points on this grid, and let's see what the look of this graph is. So we've got 0, 0, got over 0.5 up 1, so it's about there, over 1.5 up 2, it's going to be about there, 3, 3, that's going to be the same point. Oh, to the right, 3.5 and up 4, and to the right, 4 up 5 will be there. So now if I connect those together to see what the graph of this looks like, we'll have looking something kind of like this. All right, if we're looking at this, we can see that there's some symmetry. Do you notice that? So when we're looking at the domain and range of this, the domain of our inverse, remember, is going to be our input values. So that's going to be from 0 to 4. And then our range of the inverse of f of x is going to be from 0 to 5. And again, we can look at the graph to see that. Remember, our domain, we look at it from left to right, the range from bottom to top. And then if we compare the domain and range, well, it looks like here the domain of f is the range of the inverse of f. And then we can also see that the range of f is the domain of the inverse of f. So now let's look and see what we notice about the graphs. So by putting that red dotted line there, we can kind of see that something is happening there. Well, that red dotted line is actually the line y equals x. So this is a line of reflection, this line y equals x. We can see if we were to fold along that dotted line that this part of our f of x would match up exactly with this part of our inverse of f of x. And same thing up here, right? So what do we notice about the graphs? Well, we notice that they are a reflection over the line y equals x.